Everyone, in this video lecture we are going to see one topic, uninformed search strategies, from the first unit of artificial intelligence and machine learning. Objectives are to understand the various uninformed search strategies in AI and to apply the various uninformed search algorithms to the problems. Uninformed search is a class of general purpose search algorithms which operates in brute force way. Uninformed algorithms do not have additional information about state or search space other than how to traverse the tree, so it is also called as blind search. The following are the various types of uninformed search algorithms: breadth first search, depth first search, depth limited search, iterative deepening, depth first search, uniform cost search, and bidirectional search. First of all, let us see about the BFS, depth first search, breadth first search. BFS is the most common search strategy for traversing a tree or graph. It describes this algorithm searches breadth-wise in a tree or graph, so it is called as breadth first search. It starts searching from the root node of the tree and expand all this possible successor node at the current level before moving to the nodes of next level. It is an example of general graph search algorithm. BFS is implemented using FIFO-Q data structure. Now we can see one example. This is the graph. So initially the process start from the starting node. Yes, from the starting node it will explore all the possible successor. So there are two successor A and B. So the algorithm traverse to A, then from A it will traverse to B. That is, breadth wise it traverses to all nodes in each level. So from B it will traverse to the node in the next level, level 2, C. From C it will traverse to D. So in each traversing, during the traversal it will search for the goal node. Our goal node is K. It is available in the level 4. So from C it will go to the D, then to G, then H. Then it will go to the next level. So in this way it will search all the node. It will explore all the nodes breadth wise and until it reach the goal node. So this is the path, S to A to B, B to D. In this way, this algorithm explore all the nodes in a breadth wise fashion and until to reach the goal node. Advantages are, it provides a solution if any solution exists. If there are more than one solution for a given problem, then BFS will provide a minimum solution which requires the least number of steps. Depth first search, DFS. It is a recursive algorithm for traversing a tree or graph. It is called DFS because it starts from the root node and follows each path to its greatest depth node before moving to the next path. Stack data structure is used to implement DFS. It is similar to, the process is similar to BFS. So we can see the example. Normally the DFS will follow the order, that is root node to left node to right node. So in this example, this is the search tree. From the starting node, it will start from the starting node, root node, yes. Rather than the previous algorithm, it will go to the next nodes depth wise. It won't explore the breadth wise nodes. It will go to the depth wise nodes. From S it will go to the successor A. From A it will go to the successor B. Each time it will search for the goal node, and from B it will explore the possible successor. Then it is going to traverse to D. From D there is no more successor, so it is going to the parallel successor E. From E there is no successor, so it will backtrack to the previous node which is in the previous level of its parent. So from E it will traverse to C. From C it will search for the successor. So it is reaching the goal node G. So in this way, depth first search algorithm will traverse in a depth wise nodes until to reach the goal node. Advantages are, DFS requires very less memory as it only needs to store a stack of nodes on the path from the root node to the current node. It takes less time to reach the goal node than BFS algorithm. Third algorithm is depth limited search algorithm. This is similar to the depth first search algorithm, but there is a depth limit in one particular level. So below that the traversal will not happen. So that algorithm will stop in the particular limit. So in the algorithm, the node at the depth limit will treat as it has no successor node further. So depth limit search can be terminated with two conditions of failure: standard failure value, cutoff failure value. So let us see the example for the same search tree, and our goal node is J. So here the depth limit is constrained to the level 2. So after level 2, the search will not go after the level 2, since there is a limit, a depth limit in the level 2. So when the algorithm reaches the node C, it will consider there is no more successor from C. So it will traverse to the next possible node in the same level, that is D. So from D, it will consider it won't go to its successor. Then it will go to the backtrack to the previous level node, that is it will backtrack to the new node B in the previous level, and from B it will go to the successor in the level 2 I. From I it will search for another successor in the same level, so it find out the solution node or goal node. So in this way depth limit algorithm works. It is similar to the depth first search algorithm, but the depth is limited in some level. Advantages is memory efficient. And the next algorithm is uniform cast search algorithm. Uniform cast search algorithm is used for traversing a weighted graph or tree. This algorithm comes into play when a different cast is available for each edge. The primary goal of the uniform cast search is to find a path to the goal node which has the lowest cumulative cast. It expands nodes which has the lowest cumulative cast. It expands the node according to their path cast from the root node. It can be used to solve any graph or tree where the optimal cast is in demand. Let us consider the tree to show the operation of uniform cast search. So from S root node there are two successors are there. Here the cast value should be shown for each and every node, for each path from one node to another node. So there are two paths are there from S to S, S to A, S to B. So the algorithm will compare the cost value of these two paths. It will traverse through the path which has the lowest cost. So it will choose the path S to A. From A there are two nodes C and D. When compare the cost values, the A to D is least cost path, so it will go to D. So in this way it will choose the path with the minimum cost until to reach the goal node. So this algorithm is called as uniform cast search. Iterative deepening depth first search. It is also the basic uses the basic concept of depth first search, but there is a iterative method will be used to reach the goal node. Okay, this search algorithm find out the best depth limit and does it by gradually increasing the limit until a goal is found. This algorithm performs depth first search up to certain depth limit and keeps increasing the depth limit after each iteration until the goal node is found. So here is an example for the tree. There are the levels where the nodes are available and our goal node is G. The first iteration, at first the searching will start from the root node A. From A it will traverse to B, then from B it will traverse to C. And in the third iteration it will go for the next iteration. When it go for the next iteration, the depth limit will be increased to the level 2. So it will change the path. It will backtrack and change the path. So from B it will go to D. Then from D it will go to E, then to C, then to F, then to G. Even though it reaches the goal node, again it will go for identifying the best path to reach the goal node, and it will increase the depth limit. Now it will update the depth limit. So now the depth limit will be updated to the next level, level 3. So in the fourth iteration it will change the path. So from D, uh, from D it is going to H, then H to I to E, E to C, C to F, F to K, then K to G. So in this way this algorithm performs and changes the path in each iterations, and it will update the depth limits in each iterations, and finally it will reach the goal node. The advantages are, it combines the benefits of BFS and DFS search algorithm in terms of fast search and memory efficiency. And the final next uninformed search strategy is bidirectional search algorithm. Bidirectional search algorithm runs two simultaneous searches, one from the initial state called the forward search and another from the goal node called as the backward searches to find out the goal node. It replaces one single search graph with two small subgraphs in which one starts the search from an initial vertex and the other starts from the goal vertex. The search stops when these two graphs intersect each other. Bidirectional search can use the search techniques such as BFS, DFS, DLS, etc. Now we can see the example. The algorithm, let us consider the below search tree. The algorithm divides one tree into two subgraphs or two subtrees. It starts traversing from the node 1 in the forward direction and start from the goal node 16 in the backward direction. The algorithm terminates at 9 where two searches meet. So the 9 is intersection node. Advantages of bidirectional search is, it is fast when compared to other algorithms. It requires less memory only. So that's all about the various uninformed search strategies available for AI problem solving. Thank you.